we can name this compound. Why this word was used, if possible, is that generally, take note of this, generally the name of a compound is not gotten from the empirical formula. We get the correct name of a compound from the molecular formula. From the molecular formula, not empirical. However, there are times that empirical formula will be equal to molecular formula. When you have such a case where empirical formula is the same as molecular formula, then it means you can get the name of the compound from the empirical formula because it is the same as the molecular formula in that case. For this problem, we can name this compound. This compound is the reaction between ammonium ion, NH4+, and chloride ion. Under valency, I taught you how to do this. So the name of this compound is ammonium chloride. Okay? There are some cases empirical formula will not be the same as molecular formula. Take note. In that case, to get the name of the compound, you must get down to the molecular formula first. In this video, I will be showing you how we can use empirical formula and the relative molecular mass of a compound to determine the molecular formula of that compound. Recall, I stated that once you know the relative molecular mass of a compound, you know the empirical formula of that compound, then you can get the molecular formula. So here we've got this question. A compound contains 2.00 gram carbon, 0.34 gram hydrogen, and 2.67 gram oxygen. The relative molecular mass of the compound is 60. Calculate 1. The empirical formula of the compound, 2. The molecular formula of the compound, and 3. You are to state the name of that compound. Now, to solve this problem, we are going to follow the same pattern as the previous question, okay, where we just determined the empirical formula of the compound. But there is something we should notice here. In the previous question, we were given the percentage by mass of the element that made up the compound. That compound was ammonium chloride. We were given the percentage by mass. But in this question, what we have here is reacting mass. Does it mean that the way we obtain the empirical formula here will be different from that which we did in the previous question? No, it's still the same thing. In this case, the reacting mass is acting as the percentage by mass. So let us see how we solve this problem, okay? I'm going to be a bit fast in it. Remember, the first thing you do is to bring out the element, alright? So we have the elements, and the elements are carbon, hydrogen, and what? Oxygen. These are the elements. And then we will proceed to look at the reacting mass is given to us. Reacting mass. Reacting mass. So from the question, the reacting mass of carbon is 2. So I'm going to put 2 here. That of hydrogen is 0.34. And then oxygen is 2.67. 2.67. These are the reacting masses. What do we do from here? Once we know the reacting mass, we are going to obtain the mole ratio of each element in this compound. We don't know the compound here, you know. So we'll proceed for the mole ratio. The mole ratio is going to be obtained from the reacting mass. So mole ratio, that's going to be equal to reacting mass. Reacting mass, we'll divide it by the relative atomic mass. I can say the molar mass. Are you following? Okay, reacting mass over molar mass. Remember, in this case, the molar mass is still serving the function of relative atomic mass. The relative atomic mass of an element is the same as the molar mass of that element. Take note. It's just that we don't usually like using molar mass for elements. When you hear molar mass, it's either the thing is a molecule or a compound. But the value of molar mass is still the same as the value of relative atomic mass. I'm saying this because this molar mass, in the previous question, what I wrote there is relative atomic mass. So it's still the same as the RAM of each element here. Come to carbon. What is the relative atomic mass of carbon? It is 12. I'm sorry that I didn't give it here. Like I stated, generally the relative atomic masses of the elements are supposed to be given to us. but we know them, I want to believe, so we can just apply them, okay? Carbon, the relative atomic mass is 12, so it's going to be 2 divided by 12. And then we have oxygen, 0.34, the reacting mass. We are dividing it by the molar mass or relative atomic mass, which is 1. Come to oxygen, do same, 2.67 reacting mass divided by RAM of oxygen, which is 16. Now if we work on this, let us see what this is going to give to us. Let's see. The first is 2 divided by 12. And 2 divided by 12 gave me 0.16666, approximately 0.167 in 2 decimals. So I'll write that 0.17. 0.17. Okay, then we move on. 0.34 divided by 1 will give us 0.34. And then 2.67 divided by 16, that gave 0.16687, approximately 0.17. Now, what we do from here is to divide this mole ratio through by the smallest ratio. I'm going to put that down here. Divide by the smallest ratio. Okay, divide the mole ratio. Divide the mole ratio by the smallest ratio. By the smallest ratio. So let us see what that gives to us. From here, the smallest ratio is 0.17. So we'll come to that of carbon. Remember that we have carbon, hydrogen, and what? Oxygen. Alright, so 0.17, we are dividing it by 0.17, which is the smallest ratio. Hydrogen, 0.34, we'll divide by 0.17. Oxygen is 0.17, we'll divide it by that 0.17. So this will give us, here is 1, we put that down, 1, 0.34 over 0.17 should give us 2. 0.34, let's find out, 34 divided by 0.17, good, that is 2. And then this 0.17 over 0.17 will give us 1. So this is the ratio we need, alright? The actual mole ratio that we need in the empirical formula. I will now conclude. Therefore, the empirical formula of the compound is, now I'll bring down carbon. How many do we have as the mole ratio here? 1. No need of putting the 1, I've told you that already. So hydrogen is 2 and then oxygen is 1. And this is our answer. We've gotten the empirical formula. Remember, the very first work here is the empirical formula, number 1. Let's move on to number 2. We are to determine the molecular formula. How do we get the molecular formula of this compound? How do we determine molecular formula? Very important. It might interest you to know that there are just 2 things we need in order to determine the molecular formula of a compound. And what are the 2 things we need? We need the empirical formula of the compound, and we need the relative molecular mass of the compound. Once we know the empirical formula and the relative molecular mass, we can use it to get the molecular formula of the compound. So this is what we do. We have these formulas here on the board. This equation that we use to determine the molecular formula. Like I said, you need the empirical formula as well as the relative molecular mass of the compound. So once you know of the empirical formula and the relative molecular mass, all you need is to determine this whole number multiple of the empirical formula. This n here represents the whole number multiple of the empirical formula. Look at this. Molecular formula is a whole number multiple of empirical formula. Which simply means to get molecular formula, it's to multiply the empirical formula by a given whole number. And that whole number there is our n. So when a problem is given to you to get a molecular formula, all you do is pretty simple. It's much simple. Get the empirical formula first. In such question, you will be given the relative molecular mass of the compound. Then use this equation. From the empirical formula that you obtained, you will determine the relative molecular mass of the empirical formula. Then multiply it by this whole number multiple n and make it equal to the relative molecular mass of the compound given to you. Once you do that, you will get a simple equation which you use the knowledge of mathematics to solve. With that simple equation, you get the value of n. Once you get the value of n, your molecular formula will now become the empirical formula you got. Multiply it by n, that is, multiply the atom. Are you following, right? Multiply the number of atoms of each element in the empirical formula by the value of that n you got. Remember, n is always a whole number. So, to get the molecular formula, recall that the relative molecular mass, alright, of the empirical formula, multiplied by some whole number n will be equal to the relative molecular mass of the compound. Relative molecular mass. Here it was given to us to be 60. Now let us determine the relative molecular mass of the empirical formula. The empirical formula is CH2O. So if we were to get the molecular formula, this will simply give us the RAM of carbon multiplied by its number of atoms here, which is 1. And carbon, the relative atomic mass is 12. So it's going to be 12 times 1. Then we go to that of hydrogen plus relative atomic mass of hydrogen is 1. We're going to multiply it by the number of atoms here, which is 2. And then plus relative atomic mass of oxygen. And the relative atomic mass of oxygen is 16. We'll multiply it by 1 here. So 16 times 1. All of this multiplied by n should be equal to the relative molecular mass of the unknown compound here, which is 60. Okay? Now if you work out this will give us 12 plus 2 plus 16 multiplied by n equal to 60. If you add up this, you get 30. So this is 30n equal to 60. Therefore, the value of n, n is equal to 60 over 30, which will give us what? 2. This is the whole number multiple of the empirical formula that will give us the molecular formula of a compound. And molecular formula of a compound is if you determine its relative molecular mass, it will give you this term here. Alright, so what do we do? Remember that I told you that molecular formula is a whole number multiple of what? Empirical formula. So now that we've gotten that whole number multiple, which is 2, we can now say that the molecular formula, it implies that the molecular formula, alright, is equal to the empirical formula, then we multiply the atoms in the empirical formula by a whole number multiple, which is n. Now that is going to give us, empirical formula is CH2, that is CH2O. So we are going to multiply it by n, and the value of n is what? 2. Let's do that and see. This would give us this carbon. What is the ratio here? 1. Use that 1 to multiply this 2. Then you're going to get C2. The ratio of hydrogen here is 2. If you use it to multiply this 2, you get 4. And the ratio of oxygen is 1. Use it to multiply this 2, you get 2. You can still rewrite this compound as, or pick 1 carbon from here, you have C, then pick 3 hydrogens from here, that gives us CH3. Then you'll be left with 1 carbon. We have 2 oxygen here, the remaining 1 hydrogen you put it here. That compound is called ethanoic acid. It's an organic compound. So that will take us to the third question. We've gotten the molecular formula. This is the molecular formula. This is the molecular formula, any one of these. So we conclude with the name of the compound. The name of the compound is ethanoic acid. Ethanoic acid. That's the name of the compound. The third answer. And that is how we solve this problem. You can see the way I determined the molecular formula. Simple. Once you get empirical formula, determine the relative molecular mass of that empirical formula. Use it to multiply an unknown, which is a whole number multiple. I used n there. You can use any other alphabet. The choice is yours. Now, you know how to calculate relative molecular mass of anything already. Like in this case, the empirical formula is CH2O. So look at it. RAM of carbon is 12 times its ratio here, or its atom here, which is 1, plus RAM of hydrogen is 1 times its ratio, which is 2 here, plus RAM of oxygen is 16 times its ratio, which is 1 here. That gives us the relative molecular mass of the empirical formula. Then we'll multiply by n, equate it to the relative molecular mass of the unknown compound. And here they gave it to us as 60. The rest is just to solve out. If you work out this, you get that n. Then conclusively, to get molecular formula, go back to the empirical formula. You can see that the empirical formula, multiply each ratio there by n. You can see that carbon is 1 times 2, so get that. Hydrogen is 2 multiplied by this 2. Then oxygen is 1 multiplied by 2. Now I decided to rearrange this, okay? I'm sorry that we are yet to treat organic compounds.